Hello everybody and welcome back to another video. Today I'm watching what happens if you destroy a black hole by Kurzgesagt. I'm going to immediately assume that everything in this video is completely hypothetical and there is no solid evidence to any of this because it's about destroying a black hole. I mean, how do you destroy something that just swallows and eats everything you throw at it? Sounds pretty impossible. But maybe it isn't, so let's check it out. Link to the original video will be down in the description below.
Black holes can destroy everything. But can they be destroyed? What happens if we push physics to the absolute
I'm still
limit,
saying no.
maybe even breaking it and the universe in the process? Let's create a tiny black hole about the mass of our moon in the Kurzgesagt labs and try to rip it apart. Experiment 1. Nuke it. Big booms break things, so to set the mood, let's explode the world's entire nuclear arsenal around our black hole. Boom.
That's quite a lot.
Black holes swallow
I feel like it
whatever
won't
crosses their
affect it
event
at
horizon,
all.
matter and energy. And since E equals mc squared, all the energy that enters a black hole increases its mass. The mass of a black hole is proportional to its size, so as we nuke our tiny black hole, it just gets bigger and more massive.
Yep.
Experiment 2.
It just swallows it.
Antimatter. Matter and antimatter annihilate each other. What will happen if we throw a moon's massive antimatter at it? Unfortunately, when an object enters a black hole, the black hole will completely delete its past identity, whether it's made of matter or of antimatter.
Yep.
Black holes
So
only
once again,
care about gravity,
it's just
which
gonna
only
grow.
depends on the total mass energy of an object. And the mass of a particle is the same as its corresponding antiparticle, so throwing an anti-moon has the same effect as throwing a moon. The black hole just gets
AKA
more
just makes it
massive.
bigger.
This deleting ability of black holes is pretty interesting. It means that despite their size and power, black holes are, in a way, similar to elementary particles. An elementary particle like an electron is an extremely simple object, fully specified by just 3 numbers, its mass, spin, and charge. And amazingly, the same is true for black holes. They have a mass, they can rotate, and carry an electric charge. Once a black hole forms, it doesn't matter if it comes from a collapsed star, an anti-star, or a banana, it will always be fully described by those 3 numbers, nothing
So
else.
what's experiment number
But
3?
if a black hole is basically a weird particle,
Okay, we're
could
still
we
talking
destroy it
about
with
this
an
then.
anti-black hole? Experiment 3.
we go.
Anti-black hole. How exciting.
Okay.
A particle has the same mass as its corresponding antiparticle, but
I
opposite
feel like
charge.
they would just merge into a bigger
Since a
one.
black hole has mass
'Cause
and
that's what
electric
regular
charge,
black
its
holes do.
corresponding anti-black hole should have the same mass and opposite electric charge. What if we make them collide? Sadly, the charge will just
Yep.
add up and cancel out. So after the collision, we'll
just
just
like
get
regular-
a new black hole twice as massive with no
Yeah,
charge.
just like regular black holes.
Okay, we need to think bigger and stretch physics harder. Experiment 4. Destroy the event horizon. It's true that a black hole can carry spin and charge, but even for these crazy objects, there are limits.
How would you even reach
If the spin or the charge of a black
event
hole
horizon?
becomes too large, something really weird will happen. The event horizon will dissolve. In a simplified way, we think of black holes as hiding a singularity inside, an infinitely compressed mass with such strong gravity that absolutely nothing can escape from its surroundings, not even light. This is why a black hole looks like a black sphere of nothingness. The event horizon is the outer edge of this ultimate prison. Cross it and you'll never be able to come back. But when a black hole rotates, it works a bit like a spinning washing machine. It's as if the rotation wants to repel nearby objects and push them out of the black hole, which doesn't happen because its gravity is so strong.
Yeah, it sucks
But
them in.
if the rotation gets too fast, this effect will win and the event horizon will disappear. Nearby objects won't be
Oh.
imprisoned forever anymore. The same thing happens with the electric charge. Make it too large and our ironclad jail will break open. If we manage to destroy the event horizon, the singularity would still be there, and objects would still naturally fall towards it. If you hit it, you would still die horribly and quickly. But the vicinity of the singularity won't be an inescapable prison anymore. You could get as close as you want and come back. This should count as destroying the black hole. Can we do it?
I don't know.
Experiment 5. Overfeeding.
I wouldn't really count it as destroying it. The only thing I would count as destroying a black hole is just getting rid of absolutely every part of it. But I guess this is that was close enough. I guess you can count it. Personally, I wouldn't.
5. Overfeeding. All we have to do is to overcharge or overspin the black
Feed
hole.
it until it what?
We could
Just
do this by throwing
blows
objects with a
itself
small
up?
mass and a lot of charge or angular momentum
Is
so
that
that
even
the
possible,
charge or spin
overfeeding a black
increases
hole?
faster than the mass. We have to overfeed the black hole until it reaches the point where it breaks open. However, whether you can actually do this is the subject of passionate argument among physicists. Think of a
We don't
charged
know.
black hole. Equal charges repel each other, and the more of the same charges you squish together, the more they push back. So let's say that we have a negatively charged black hole, and we want to overfeed it with electrons, for example, whose charge is far larger than its mass. The electrons will feel an electrostatic repulsion, and the more electrons we throw, the larger the negative charge of the black hole will be, and the stronger the repulsion. But once we reach the upper limit, the electrostatic repulsion will be so strong that it won't allow any more electrons to come in. At this point, the black hole will refuse to be overfed.
So
With
you
the
can't
spin,
overfeed
it's
it.
similar. Once the black hole reaches its upper limit, it won't gobble more spin. But some scientists have discovered what looks like a loophole. If an instant before the black hole reaches the limit, we throw the right amount of matter in just the right way, it looks like we could actually overfeed it. Most scientists are skeptical, but let's give it a try anyway.
Yeah,
The end? Breaking physics.
that's
There
just
is a
completely
catch, though.
theoretical.
The event
No
horizon
evidence
of
to
a black
support
hole
it.
hides the singularity. So destroying the horizon would leave us with a naked singularity, one that is not hidden by an event horizon. And this poses a problem. It could mean the end of physics as we know it. There's a big dirty secret about black holes. Contrary to widespread belief, the singularity of a black hole is not really at its center. No, it's in the future of whatever crosses the horizon. Black holes
What?
warp the universe so drastically that at the event horizon, space and time switch their roles. Once you cross it, falling towards the center means going towards the future. That's why you can't escape. Stopping your fall and turning back would be just as impossible as stopping time and traveling to the past. So the singularity is actually in your future, not in front of you.
Okay, is that like backed up by any evidence, or is this just completely theoretical? Because I've never heard of this part before about how that's the future. Or maybe I did and I just don't remember it.
And just like you can't see your own future, you won't see the singularity until you hit it. But you also can't hit something that's in your future, only sort of experience it, like you'll experience your next birthday when it happens. Singularities that are in the future are not a problem because we can't see them or interact with them. But a naked singularity would be in front of us for all of us to see. What would we see? Well, the whole point is that it's impossible to know. A singularity is a region of infinite gravity, and gravity is the bending of space-time. At a singularity, the bending is so radical that the fabric of space-time is literally broken. Space and time don't exist anymore. This means that you can't predict anything, since predicting means making a forecast about where and when something will happen. But where and when have lost their meaning. So we have an unpredictable thing with infinite gravity and therefore infinite energy. This means that anything could come out of it for no reason, from a pile of bananas to lost socks or a solar system. Predictability, causality, and physics as we know it would break down. We think that singularities should exist in nature because we can prove that under very general conditions, gravitational collapse leads to the formation of singularities.
I'm kind of
However,
lost now.
scientists think that nature forbids the formation of naked singularities. Something enforces the creation of an event horizon around them to prevent their insanity from infecting the rest of the universe. Without event horizons, physics may not make sense at all. So although black holes have been portrayed as the ultimate monsters of the universe, they may actually be the heroes that keep us safe from the madness of singularities. So if we do destroy the horizon, we might destroy the fundamental rules of the universe. You know what? Let's not do that. Conclusion: the safe option. As far as we know, there's just one safe
What's the
method to
safe
destroy a
option
black
here?
hole. Wait. All black holes emit tiny
Wait?
particles, a phenomenon called Hawking radiation. This process causes them to slowly lose mass until they
So just
eventually
wait
evaporate, leaving behind
till
no
it
horizon
dies
and
out
no
on its
naked
own?
singularity. The time it takes for a black hole to completely evaporate depends on its mass. For our mini black hole, the size of a speck of dust,
But that's not really destroying a black hole. The whole point of this is to figure out if we can destroy a black hole, but this is just, I don't know, what would you even call this? Nature? No. This is just a natural process that happens. So if we don't interfere, we're not destroying it.
It will be about 10 to the power of 44 years. 10 billion trillion times the present age of the universe. So is it possible to destroy a black hole? Yes, we just have to wait. But
well,
you don't have to wait that long.
It's possible in theory, but realistically, probably not. And 10 to the power of 44, I think it said. Yeah, humanity is not going to be around at that point anymore, so we're never going to see that. But yeah, in conclusion, destroying a black hole, probably not possible. Almost certainly not going to happen. Definitely not in our lifetime, and probably just not over the course of humanity. However long humanity exists. But anyway, I hope you enjoyed the video. If you did, consider subscribing and leaving a like. If you're interested, why not watch this video right here? And with that, I hope I'll see you in the next video.